let's record. Let me make sure I'm recording, because maybe we did it and we didn't record. I think that's what happened. Right. Okay. So here, learning unit 8 is on hypothesis testing. Shucks. And now I don't have my other as a clicker. Okay. Right. So I'm not gonna do much walking today.
So is that not a title?
Wait.
So it said learning unit 6.
Yeah. No, it's a mess. It's a mess, because remember they changed the syllabus. They changed the syllabus, so these are it's still the same content, but they just changed the syllabus. So when you look at the slides, this is not the only one. When you look at the slides, chances are the learning unit is going to be different from what the actual learning unit is currently. Okay, right, but yeah, it is chapter 8 in your textbooks. Okay, right. So the key thing that we are looking at here is explaining the reasoning behind hypothesis testing, distinguish between the null hypothesis and the alternative hypothesis, then distinguish between one and two-tailed test, explain the two types of errors that may occur during hypothesis testing. We saw this in the video, but we'll briefly go over it again. Explain the steps in general hypothesis testing. That's where I wanted to take you guys at the beginning. So that is actually critical. You have to know those steps in order to actually do this. Then conduct a test of hypothesis concerning values of population mean and population proportion. So again, we're dealing with a situation where we're looking either at population or we're looking at mean. You'll see that learning unit 6, 7, and 8, they are quite connected for you guys. So if you're comfortable with those, then you'll be fine, right? Or if you have a good foundation in the previous 2 units, here you'll be fine, okay? And remember the whole idea, like I was saying earlier, a hypothesis is an assumption. We are standing on, this is the assumption that we are making, all right? Based off of information that we have, okay? And then we just conduct an experiment to confirm whether that assumption is true or not, okay? Hypothesis testing is a process that tests how close a sample statistic lies to the hypothesized population parameter, all right? The assumed population parameter or the real population parameter value to decide whether to accept or reject the management claim. Here they like to say management claim, but ultimately it's not like it's always a management claim. It can be any claim. Could be the other time when we were, I think, doing the previous unit, doing the theory to the previous unit, I made an assumption. As a lecturer, you say 90% of varsity college students don't study, all right? That's an assumption. Does that make sense? It needs to be tested. Is that true or false? Okay, so it's not always management, okay? But yeah, just so you are aware, because when you go through these slides, you just see management claim, management claim, management claim. Okay, but that's fine. Let's go on. So this is what we are focused on in this learning unit, these 5 steps, okay? First thing that you do is we define the statistical hypothesis, okay? So we read the situation, then we say, okay, what assumption can we then make based off of this situation? Then we determine the region of acceptance. When do we accept our assumption? When do we reject our assumption? Okay. Then calculate the sample test statistic. This is now where we conduct the experiment. All right. Based off of the findings, we then compare, right, to say, is the actual result of our experiment within the region where we can accept our assumption? Or is it outside of the region? If it's outside of the region where we can accept our assumption, that means that we are rejecting our assumption and saying it's false. Okay? So that's what we mean when we say reject the nil hypothesis. Okay? Then draw statistical and management conclusions. So based on whether that assumption, the students do not study or not, we can now confirm, no, actually, after we conducted our research, actually, after interviewing students, we realized, no, that assumption is incorrect. Students, actually, so that's our conclusion. Therefore, we are going to continue registering students because they're studying. Can you see? So based off of our results, we can then make conclusions, and then obviously from conclusions, we can then make strategic decisions for the business or for whatever type of entity we're involved in. Then from here, they're now just further breaking down the steps, adding more detail. All right. So hypothesis testing starts with a value being assumed. Okay. It is derived from a management question or situation, I would say. All right. Two statistical hypotheses are formulated based off of the assumed population parameter. So we spoke on the nil hypothesis, which is the one that the assumption we're either rejecting or accepting. But we also have what we call, which is also the status quo, okay? But we also have what we call the alternative hypothesis. So if we're rejecting the nil hypothesis, our initial hypothesis, then we are obviously then accepting the alternative. Okay, so they work hand in hand. It's like saying, if you don't like, all right, if you don't say yes, then you're obviously saying no. Can you see that? By virtue of rejecting one, that means you stand on the other position. Does that make sense? Okay, so that's what we are basically saying. Then you'll see that we have either a two-sided test, or you have a one-sided upper tail test, or you have a one-sided lower tail test. Okay, right. And the alternative hypothesis is the symbol for it is H1. The nil hypothesis is H0. Okay, right. I'm trying to see, is there anything? Okay, so these things are also not cast in stone, right? Your H1 and your H0 will be based off of the situation presented. And you know, in statistics, usually we will say is either less than or equals to, is either greater than, all right, or is equal to. So when it comes to the nil hypothesis, you're always going to have the equal sign relating to the nil hypothesis, okay? And then here they're just giving an example of a scenario. So here they're saying, for example, if a manager asks whether the mean output per worker is exactly 45 units per hour, then the nil and alternative hypothesis are expressed as follows. All right. So remember we said in the nil hypothesis, H0, there has to be the equal sign. Okay. So he's asking whether the output per worker is 46 units per hour. In other words, do they produce 46 units per hour? Okay. So they either produce 46 units per hour or they don't. They can either produce more than 46 or they can produce less than 46. Can you see now? You can be on either side of this 46. And this is where now we say it's a two-tail test, because you can be either more than or less than, all right? But the assumption that we are testing is, do they produce 46? Can you see that? So now what's going to be your H0? What's going to be your H1? Remember we said H0 always has to have the equal sign within it. So that means we're going to say the mean should be equal to 46, okay? Therefore, the alternative must be the opposite, right? Therefore, the opposite of not equaling 46 means it's not equal to 46. In other words, it can be more than or it can be less than, okay? So now when we run our test, right, we then are looking to see, is this sample that we are investigating, because remember, we're not, this is why I played the video earlier, we're not going to do the whole population. It's expensive, it's time consuming, all right? That's why we want to infer. We take a sample that's a good representation of the population, and then we infer our results. So, yeah, here they're basically just explaining what I I highlighted to say it can be either more than or less than, okay? And then here they're just changing the question, okay? So when we have more than or less than, then we know it's 210, okay? In this scenario, they say, for example, if a manager asks whether it can be assumed that the mean output per worker is more than 46 units per hour. So again, here can you see, you have a situation of it's either going to be more than or it's going to be less than. But again, we want H0 to have the equal sign in it. Okay, so we then say, okay, the mean here, if it is equals to 46 or less than, okay, that means that we accept our null hypothesis. If it is greater than, then we reject. Okay, right. So here they're saying the manager's claim resides in the alternative hypothesis. So the claim is not always in H0. It can be in either or. Because remember, we have a condition when it comes to H1. H0. H0 must always have the equal sign within it. All right? So if we find ourselves in a situation where we can't have the management claim in H0 because it will not allow us to have the equal sign, then it'll be in the alternative. And there's nothing wrong with it being in the alternative, by the way. Okay. Yes.
Both hypotheses have the equal sign.
No.
Only H0.
Only H0. Only H0. Okay. Right. Right. And there you can see. Now there's another. They've just reversed it. Now they're saying less than 46 units. All right. And here it's actually saying exactly the null hypothesis must always represent the statement that contains the equal sign. Okay, right. And there you now see A0, well, basically, sorry,
More than or equal to.
yes, is more than or equal to. Okay, right. Okay, right. Now here, let me go on to region. So here, how do we establish the region of acceptance? All right. In other words, how do we know when to accept or reject the null hypothesis? Okay. We have to set up a region of acceptance, and within the question, they will always tell you you must have a certain level of confidence. Okay. It can either be a 1% level of confidence, it can be a 5% level of confidence, or it can be a 10% level of confidence, okay? Right, mathematically you could go on, but in statistics usually we use those three. And the lower 1% is more accurate than 5 and 10%, and likewise 5% is more accurate than 10%, okay? Because your region for acceptance and rejection is even smaller. Okay, so here graphically, this is what we are talking about when we say a two-tailed test. We're saying the mean is 46, okay, but it can be more than or it can be less than, okay, but we're saying if our results are within this green region, then we are going to accept the null hypothesis. If it is outside of this region, the green highlighted region, then we are rejecting and accepting the alternative hypothesis.
So,
yes.
you're saying the part that is shaded green is accepted or rejected?
Sorry, I lie. It is the region of rejection. Sorry, region of rejection. Sorry. Okay, so here I just want to highlight you get one-sided upper tail test. Okay, and there we're looking at a situation where we're saying, here you can see it's a situation where your H0 is, we're saying the mean is less than whatever values we've formulated from our situation or our claim, okay? And then your H1 is obviously then saying greater than, okay? All right. And then you got the one-sided lower tail as well. Okay. Then this is what they were talking about in the video when they were saying that you can make errors. Remember here we're inferring, we're making assumptions, and you know they always say there's always the exception to the rule. So statistics, we say, okay, we want to see what is the trend. It's not to say everyone, this is the case. Okay, so here, remember they said type 1 error is where we reject the null hypothesis, but the hypothesis was actually true. Okay, and then type 2, we're saying we accepted the null hypothesis, but the null hypothesis was actually false. And I think the best thing for you to do, there is a graph here or a table. Where is that table? There was a nice table that showed, yes. Is this it? Accept, reject. This is not it. This is not it. Okay, this is just telling you when to accept or reject. Maybe I saw the table in your textbooks or somewhere else. Yeah, no, it's not here. It's not here. Okay. So, yeah. Okay. So here now they're just talking to the levels of confidence in relation to your type 1 and type 2 errors. Okay, so here now they're showing you how you actually get your level of confidence. Okay, so you divide it by 2 if it's a 2-tail. Okay, and this is something you read off of this here. So in the question again, they will tell you, okay, we want you to do it at a level of 1% confidence. Okay, so then if it's 2-tail, you will then read off this, and your reason why we said plus minus is because remember we're basically saying upper tail and lower tail. Okay, again we can have 2-tail at 5% and we can have it at 10%. Okay, 1%. If it's the lower tail, we're basically saying there's your region. So our results, all right, if they are, you'll see, it will depend on whether it's less than or equal to, then we'll say whether we're rejecting or accepting. Okay, and then we also have, at 5% or 10%. And then here we have 1% also and 5% on the upper tail as well. Okay. So those are the amounts. Now, when we do our experiment, you'll see whether it's for the mean or whether it's for the population, we are comparing it to that, to accept or reject. Okay. So here, yeah, they're just speaking to, we call it the decision rule. Okay, we need to establish, before we run our experiment, we need to establish at what point are we going to reject, at what point are we going to accept. Okay, then step number 3 is the actual calculation. So step number 1, we are setting up our hypothesis. Step number 2, we are setting up our region of rejection. Step number 3, we are running the actual test. We calculate off of the sample. Then step number 4, we compare the sample statistic, all right, to the area of acceptance or the region of rejection. Okay, we use both, but we're obviously referring to the same thing. Then number 5, as we saw on that initial, I think it was slide number 4, this is now where we draw a conclusion based off of our comparison in step number 4. Okay, so this is why I was saying all that we are doing in learning unit 8 is obviously those 5 steps. Okay, so in our next session we'll jump into those revision exercises. Okay, so here they're just talking more about your management conclusion, but otherwise that is it. And here now they start to give you guys examples. So go through these examples when you have time, I'd advise go through the examples and then redo the revision exercises in your own time. Learning Unit 8 is actually a good unit. You want me to go? Keep going. Yeah. It's just examples until slide 73. Slide 1 to 30 is where the actual content. So you see here, example 8.4. And yeah, then they give you the solution. They take you through the relevant steps. Yeah. So I think it's 2 or 3, maybe 3. I think 3 examples. Yeah. Okay. Right. So let us take a break, and then when we get back at 10 past, we are going head first into exercises.